All right, we're going to talk about trig functions of any angle. So it doesn't even have to have a radius of 1. So we're no longer on the unit circle anymore. Okay, so it says here, let theta be an angle in standard position with x, y, a point on the terminal side of theta, and the radius being the square root of x squared plus y squared, which does not equal 0. Okay, so first let's just visualize this here. Okay, so let's say I'm just going to put, oops, let's use a different color. I'm just going to make this theta here. And this was r, my radius, which again, I just said, that no longer has to be 1. We're not on the unit circle. So this would be theta prime in this situation, right? This is that ordered pair x, y, whatever we're given, which now this would be x and this would be y. So that being said, we know that sine of theta would be y over r. We know that cosine of theta would be x over r, and tangent of theta would be y over x. Now, the difference here, like I was saying, is that now r doesn't have to be 1 like it was on the unit circle. Likewise, we have cosecant of theta is r over y. Just finish filling these out here. Secant of theta is r over x. And cotangent of theta is x over y. So now with this information here, let's try some different scenarios, trig functions of any angle. It says here, given that the secant of theta is greater than 0 and cotangent of theta is less than 0, in which quadrant does the terminal side of theta lie? You're going to have to think about this. Go ahead, put me on pause. Let's see what you come up with. All right, so the correct answer here is quadrant 4. Think about where secant of theta being greater than 0 has to lie. And then where does cotangent of theta less than 0 have to lie? So the only thing that they share in common would be quadrant 4. Next one. Given the point that -5, -12 lies on the terminal side of theta, find the sine of theta, cosine of theta, and tangent of theta. I know you guys can do this. See what you got. All right, so it helps here to think of this graphically first. We know that -5, -12 would be in the third quadrant. Okay, let's draw our triangle here. -5 in the x direction, -12 in the y direction. Then we can figure out our hypotenuse there using our Pythagorean theorem. So sine of theta is -12 over 13. Cosine of theta is -5 over 13. And tangent of theta is 12 over 5. Next example here, it says, given that 3y plus 2x equals 0 is the terminal side in quadrant 4 of beta, find all 6 trig functions of beta. My hint for you is that understand that this is an equation of a line. All right, go ahead and try this one. All right, so a quick check here. I gave you a hint that this is an equation of a line, which if I solve for slope-intercept form, I get y equals -2/3 x. So using that line, I can figure out that 3 and -2 is a point on that line. We want it to be in quadrant 4, so I can find that hypotenuse here is square root of 13, which allows me to find the remainder of my 6 trig functions of beta. Also, just reminding you that you did not have to rationalize the denominator. Next example, given that cosecant of theta is 4 and cotangent of theta is less than 0, find the cosine of theta and tangent of theta. So see what you guys can come up with using this given information. Go ahead and put me on pause. Actually, put me on pause. You still haven't, have you? Okay, so using this information, I started by realizing that for cotangent of theta, that it would have to either be in quadrant 2 or quadrant 4 if it's less than 0. And then cosecant of theta equaling 4, we'll understand that that's just a ratio of 4 to 1. And it made it a ratio of 8 to 2, and so on. So I was able to draw my triangle, find out that that adjacent side was negative square root of 15, and then get my two trig functions there. Last example, it says, find cosecant of theta given that cosine of theta is negative 4/5 and theta lies in quadrant 3. Use this information, let's see what you get. All right, so I use that cosine of theta is negative 4/5 and lies in quadrant 3 to draw this here. I could find out that this side opposite of the angle here is negative 3. So found cosecant of theta is negative 5/3. Now I understand that all of these examples that we went through are really similar. Like they're asking for a variety of things using similar methods. You know, we're drawing this picture every single time, using what's given, finding a third side. It's just good to go through examples that have different pieces of given information.